Yo guys, and welcome back to another video. Today we are going to take a look at one of the most interesting light effects that we can see just by pulsing or strobing the light at a particular frequency. This effect is called the stroboscopic effect. We will be going to see how this effect works, and we also will be going to make a stroboscopic light. So let's get started. To understand basically how this effect works, we have to first take a motor and then stick something like a cardboard or paper disc with a mark on it. Now as you can see, in complete darkness, when we switch on the normal light, we can see that mark spinning. Now if I try to blink the light, then you can see that it is starting to get weirder, and as I reduced the speed at which the light blinked to some less amount, at a point the mark starts to stop. This happens because the speed at which the light is blinking is same as the speed at which the motor is completing one cycle, and hence when the light flashes on the disc, the mark is at the same place at which it was in the last cycle, so it appears to be stationary to our eyes. Now this effect is useful in many ways, as we can measure the speed of various rotating objects. We can also stop the motion of various things like rain falling on to make it look like it stopped in air. This specific effect was used in the film Now You See Me Too in the rain magic scene, if you guys know what I mean. This effect also causes the infamous wagon wheel effect, in which the wheels appear to turn or rotate backwards. Now this was pretty much all about the stroboscopic effect. So let's now see how to make a stroboscopic light using an Arduino. If you don't have Arduino, you can check out the link in the description below, in which I have linked a circuit which you can make using 555 timer IC. It pretty much does everything what this Arduino can do in this scenario, but has a little less range of frequency for operation, but it mostly covers the needed one. For making this using Arduino, we need an Arduino microcontroller first of all. Uno, Nano or any microcontroller will work here, as the code is fairly simple and only needs 3 to 4 digital pins and an analog pin. Then you need a 10K potentiometer with a switch system to turn the light on and off. A couple of 10 kilo ohm resistors, 2 tactile push buttons, some male header pins, and wires are also needed. Then simply connect the circuit according to the given circuit diagram in the description below. You can simply connect the potentiometer between plus 5 volt and ground, and the middle pin of the potentiometer to analog A0 pin. Then connect the push buttons between plus 5 volts and digital pins 2 and 4. Similarly, connect the resistors between ground and digital pins 2 and 4. Then connect the potentiometer switch to the LED lights positive, which is then connected to digital pin 3. Now if you want to connect it to any other pin, make sure the pin is PWM or pulse width modulation supported by checking the sine wave symbol next to the pin on the board. Then connect the LED lights negative to ground, and so the circuit is complete. Now let's look at the coding of the Arduino board. In the code that we made, first we have declared some variables that will be used later on. The variable multiplier changes the value that your button multiplies the frequency with. So as you can see, it is set to 2. That means whenever I press one button, the frequency will be multiplied by 2 and divided by 2 when the other button is pushed. This helps to find the perfect frequency of rotating objects easily, as when you see the blades of fan twice or your mark twice, simply press the button to half the frequency and you have got the desired frequency. This makes it a lot easier. You can, by the way, change any value what you want to customize the code to your needs. Then we defined the push buttons and the output LED pins. We also defined the serial output. Then we made a function to check the button press. This makes it easier to add more buttons in future if you want to do more tasks with them. Then there is the main code, which first of all holds the light for a given time, which is set by the hold variable, which basically depends on the sensor value, that is the potentiometer input to the analog pin. Then after a given time, it turns the light off for a given time so that we can see the lights blinking, that is 2% of hold time. Then basically it calculates the frequency and the speed in rounds per minute or RPM and outputs it to the serial monitor. Then there is the condition for the button, that if button 1 is pressed, then multiply the factor by multiplier, and if other one is pressed, then simply divide the factor by the multiplier. This basically sums up the code, which was fairly simple. But if you have any problems, shoot us with them in the comment section below. You can download this code from the link in the description below. Now after you have uploaded the code to your Arduino, simply connect the wires to it from your circuit and then power it on. As you can see the output in the serial monitor, which shows the frequency as well as the RPM of the object at which we hit light. So that wraps up this video, guys. Make sure to hit the notification bell, obviously after subscribing. Thanks for watching.